So the goal for today is we're going to find the area, right? And I'm going to, what is the area of this region? And they like find the area of this region bounded by, and they give you stuff. And the easy ones look like this. Find the area of the region bounded by y equals x squared plus 2, y equals negative x equals 0, and x equals 1. Right? Right? This is an example of an easy one. Right? Find the area bounded by, and they give you stuff. Right? And you're going to hear this a lot. You know what the first thing you do is? Draw a picture. Right? You cannot answer these without drawing a picture. It doesn't have to be a good picture, but you have to draw a picture. Right? There is no way you can answer this without drawing a picture. Some smart aleck person will say, well, I didn't draw a picture. I said, yeah, you did. You just did it in your head. But you need to see what's going on. So here's our picture. All right, so we got this little parabola shifted up 2. Yay. Y equals negative x. Here's a line that does this. Yay. Everybody all right? We're drawing our picture. It says x equals 0, so I get a line here, and I get x equals 1. I get a line here. Can everybody see the region bounded by all of these? And just to be sure, this is the region we're talking about. Everybody see it? And our goal is to find what is this area. Right? Now we've already done a little bit of area because we've talked about when you take the integral, that gives us the area between the curve and the x-axis. All right, now I need everyone to draw this picture. So everyone draw in this picture. So there's two incredibly important things you do. First is draw the picture. And the single most important thing you can do is this next thing. We need to draw a rectangle. Right? Now, in years past, when I do the rectangle, I actually physically draw a rectangle where I'll do I'll actually try to make it look like a rectangle, and I realize that's way too much work. Your rectangle is literally going to be a line. It's going to be a really skinny rectangle. And so I want everyone to draw their really skinny rectangle. Technically, that's got some width. Not much width, but it's got some. Has everybody got that? Okay. Now, here's what we're going to do. I need to find the area of that rectangle. And the area of that rectangle is it's got a height and it's got a width. The width of this rectangle, because it's along the x-axis, is going to be dx. A little bit later, we're going to talk about when your width is along the y-axis, but that's not now. It's one of the last examples today, right? And the height of your rectangle, and I need everybody to remember this. How you figure out the height of this rectangle, it's top minus bottom. And so when I think top minus bottom, top function minus bottom function. And so what's your top function? X squared plus 2. What's your bottom function? Negative x. Everybody see where I got top minus bottom? All right? Now, this is one skinny rectangle. And depending on where you drew it, right, it's top minus bottom. What I want to do is, can you imagine that there are a bunch of little rectangles? Like you could draw a bunch of little vertical lines? And if I want to find that total area, I want to add up all those rectangles. And the way you add up all the rectangles is you do an integral. And this says sum up all my representative rectangles. And where do my x values go? What is the smallest x value?
0 to 1.
All right? And are we okay from 0 to 1? Our rectangle goes from 0 to 1.
Wait, why is it negative x and not like x equals 1 at the bottom function?
What here?
Yeah, why is
What's this function? When you're doing top minus bottom, it's
like
top.
actually on the graph, the lowest y value.
No, I'm not looking for the lowest y value. When I say top minus bottom, that's actually short for what is the top function minus the bottom function. And this top function is x squared plus 2. And this bottom function is a negative x. Right? So I get you. Thank you for making me say that. When I say top minus bottom, that's short for I want the top function minus the bottom function. And drawing that rectangle is crucial for everything that we're going to do for the next week. Right? Now, can we compute that integral? Right? I am going to cut some corners today because just out of time. Normally, every problem I would do, I'd finish the problem. I will finish this one, but the rest of them it'll be focused on how do we set it up, and then assuming that you can find the final answer. And actually, in your homework, what I'd rather you do, set it up, and then go ahead and type it in a calculator to come up with the answer. Does everybody know how to type this in a calculator?
No.
No. Okay. Here. You got an 84? Who needs an 84? Just so you can see what it looks like. It's real. Here, let me press pause. Problem. So these are the easy ones. Because when you draw it, it's like clearly defined what your shaded region is, and you even know, hey, I'm stacking them from here to here. Perfect. All right, so how does it get harder? Well, they stop giving you as much stuff. For example, what if I ask you to find the area between y is equal to 2 minus x squared and y is equal to x? So what do you notice? What did they not give us?
They didn't give us bounds. So would this be
They didn't give us
indefinite?
X.
Yeah, they didn't tell it. They weren't obvious about where x starts and x stops, right? Well, I'm going to go back to my first statement. What do you do first?
Draw a picture.
Draw a picture. So we draw the picture, and let's see, 2 minus x squared, that's over here, right? That does this thing. Y equals x. That does this. Do we have a region that's bounded by the graphs?
Yes.
Does everybody see this is what we're talking about? Okay, now, whenever this happens, and it will, your job is you got to figure out those intersection points.
So that's where they equal the same thing?
That's where, yeah. So how do we do that?
System of equations.
Well, yes, or, well, so, well, yeah, but there's, y'all are all going around it. No one's telling me what to do to solve it.
Plug in x for y in the first equation. Say-
How about set these equal to each other?
Yeah. Substitute.
Yeah, okay. But there, if you're looking for intersection points, that's where the equations are equal.
Yeah.
And so if I set the equations equal, let's see, that's going to give me x is equal to 2 minus x squared. And anytime you see x, right, x squared and x in a number, you set it equal to 0 and hope you can factor. So this is going to give me x squared plus x minus 2 is equal to 0. This is going to factor as x plus 2, x minus 1. And so end up with x is equal to negative 2 and x is equal to 1. Is everybody okay with that? I need coordinates. Well, it's easy. I'll use this one. So this is the coordinate negative 2 comma negative 2. And this is the coordinate 1 comma 1. Okay. Has everybody got that picture? All right. Now, the most important part, draw your rectangle. Everybody draw your represented rectangle. Draw it somewhere in the middle. You want to make sure it doesn't cross at any nice spot because it'll just mess you up. Is everyone drawing a rectangle? And so when you draw your rectangle, I need to get better with using colors. Is everybody okay? That's your rectangle?
Does it have to be in a certain spot?
No, it can be, honestly, it can be anywhere. I would prefer you not to draw it, it touches at the origin, because I think that'll mess you up later. I want it kind of in a general, I mean, you could draw it here, you can draw it here. I really don't care where you draw it. And so now we're going to set this up. And so the width of my rectangle is dx. And I need top minus bottom. What is your top function?
2 minus x squared.
2 minus x squared. What is your bottom function? X. And when we set up our integral, where are we stacking our rectangles? From where to where?
-2 to 1.
Perfect. Does this make sense? Right? I can't tell you how important drawing that rectangle is. Right now, you might think I'm crazy. Well, I mean, obviously, no sane person would be a high school math teacher. But, all right, drawing that rectangle is going to make your life easier when things get really complicated. Right? Things are not really complicated yet, but they're about to be. And if you can draw that rectangle, you just made your life a lot easier. And you have to understand it's top function minus bottom function. Is everybody okay? And again, you can type that in the calculator. I don't care. I care about this.
So we're going from -2.
Right? And that -2 to 1, that's just telling us where are we stacking our rectangle. Our rectangle kind of x value starts at -2 and it goes to +1. Right? You can almost envision it moving around. All right, everybody okay with this one? All right, next. I'm going to skip the trig one. So let's do y is equal to 3x cubed minus x squared minus 10x. And y is equal to a negative x squared plus 2x. You know what? I need to color code some stuff. Where's my green? There's the green.
What's the second one?
I just want to color code them, right? Because we can talk about the blue function and talk about the green function. All right, so I need to graph this. And you don't have to be good at graphing them, right? Let's see. So I'm going to graph the blue one. I could factor it and find out. What you would do is you'd end up factoring this, and it's not terrible. It's x, and you get an x squared, 3x squared minus x minus 10, and so it's going to factor as x minus 2 and 3x plus 5. Yeah. And so it crosses at 0, crosses at 2 and 0, and then almost -2. But I don't need to know that crosses there. And
This is all for the purpose of drawing the picture.
what?
This is all for the purpose of drawing our picture.
Yeah, what's really important is the 0 and the 2. The fact that it's over here doesn't matter. And it just sort of goes up here, comes down here, and does this. And I'm not asking you to be experts at drawing this, but is this picture reasonable with this? Right. When I draw the green one, well, that's an upside down parabola. It's going to cross at 0 and 2, so it's here and here. And I'm going to be really bad at drawing this, but it kind of looks like this. And this is a not great picture of it. But first, so I need everybody to do your best to reproduce this. Actually, y'all will do a better drawing of the picture than I just did, but do your best to reproduce that. How many regions do we have? Does everybody see we have 2 regions? That's not the bad part. Here's the bad part, right? You've got 2 regions, so I'm going to put a rectangle in this region.
I see
Why?
why. Because the top function becomes the bottom function.
Right.
So you have to calculate both.
Did y'all see that?
So you have to calculate from,
So let's look at the red rectangle.
ooh, that's weird.
Yes. Right? Notice how in the red rectangle, the top function is blue and the bottom function is green. But in the orange rectangle, the top function is green, the bottom function is blue. Does everybody see that? That's the part that makes it mean. But we're missing something. We need these intersection points. So yay, algebra. I got to set these equal to each other and solve, because I've got to find those intersection points. And so if I set 3x cubed minus x squared minus 10x equals negative x squared minus 2x. And one good thing, this cancels. And if I add the 2x to both sides, that's going to give me 3x cubed. What does that give? Oh, wait, where did I mess up?
Is there a negative two for the problem? Negative.
No, this was, wait, where did I mess up? No, that was a plus 2. I didn't copy, yeah, that's, sorry, messed up. So that's a plus 2, and so that gives me a minus 12x. Now that looks like what I had. Set that equal to 0. I'm going to factor out a 3x. So that gives me x squared minus 4, x plus 2, x minus 2. And so I end up with x is 0, and x is equal to 2, and x is equal to negative 2. And so there's the 0, there's the 2, there's the negative 2. So this is the coordinate 0, 0. This is the coordinate 2, 0. This is the coordinate negative 2. And 4 minus 4, negative 8. All right? So, this red rectangle, I'm going to set that up as an integral with the red pen. So if I want to know what this rectangle is doing, first of all, where are we stacking our rectangles? From what x value to what x value? Negative 2 to 0. So this is going from negative 2 to 0. And what's your top function minus your bottom function? Okay. 3x cubed minus x squared minus 10x minus the bottom function, which is negative x squared plus 2x. And there's a dx. Does that make sense? Does everybody see this as that red rectangle? Okay. Now the orange rectangle. Where are those rectangles being stacked from?
Would this be calculated?
No. Notice how this rectangle is going from 0 to 2? So this is going from 0 to 2, and then I'll do top function minus bottom function. And what's the top function in this one?
Negative x squared minus 2x.
Okay.
Would this be multiple choice?
Could be. But you still have to come up with the answer without a calculator. Okay. So end up with negative x squared plus 2x minus this thing, which is 3x cubed minus x squared minus 10x dx. So you find that one and you find this one and add them together. So, does everybody understand that? Do you understand why it's tricky? I've actually seen, it was a multiple choice question where they did, and it actually had 3 different intervals. And so you had to set up 3 different intervals. You had three, and it kept flipping. Yay. Okay. All right. So, did everybody see what happened? All right. And so now, here's the main part of today. Good, and I have enough time to actually talk about it.
Mr. Roberts,
Yes.
when you find those two integrals, do you add them together? to
Yes.
find the area?
When you're finding those integrals, like when you found that, I shouldn't have erased it, but when you find the first integral, that'll be a positive number. When you find the second integral, that'll also be a positive number. If you ever find an integral and it's negative, when you're trying to find the area between two things, that means you got confused what was on top and what was on the bottom. All right. So now, what about find the area bounded by the region y equals 0, y equals the square root of x, and y equals x minus 2.
Square root of x is,
Yep. Okay, so let's draw a picture. And let's see, here's the square root of x, which kind of does this thing. There's this thing. And then x minus 2 is this thing. All right, is everybody okay? Does everybody see this is our region? All right, so draw your rectangle. Remember, because that's the way these work. You draw the picture, and then you draw your rectangle. Does everybody draw a rectangle? What?
two rectangles.
Oh, you're good. Does everybody see that you need two rectangles? All right. Like you can draw this rectangle, and then you have this function minus this function. But that doesn't work, does it? Doesn't give you everything. You also have to draw this rectangle, don't you? So you have different.
So you have to find the intersection between the other two.
You need to find this. That's kind of easy, though.
I mean, that's where 0 and -2 intersect.
Yeah, well, I mean, it's a slope of 2. This has got to be the coordinate 2, 0.
It was a worse problem in my opinion.
Yeah, worst problem, but this one's not so bad. And then to find that intersection point, we're going to set these equal and solve. And so when I set them equal, that's going to give me the square root of x is equal to x minus 2 and square it. Actually, set this equal to this. And let's square both sides. So I end up with x is equal to x squared minus 4x plus 4. So 0 is equal to x squared minus 4x minus 5x plus 4 minus factors. It's going to give me an x minus 4, x minus 1. I get x is equal to 4 and x is equal to 1. X equals 1 doesn't make a whole lot of sense, but x equals 4 seems reasonable. And so this is going to be the point 4, 2. Because if you plug 4 in, 4 minus 2 gives you 2.
So how do you know the x value is 2 for the original y equals 0?
It's for later. when you have
Okay.
the time.
Okay. How did I know this was 2?
Yeah.
You have a line with slope 1 that starts at -2. So if you have a slope of 1, if this is 2, that's got to be 2.
But why didn't it fall in the other function on y equals square root of x?
Square root of x is only the top half. Yes. Yeah. Although, could you wait 5 minutes?
Yeah.
Okay, because there's something tricky that's about to happen.
Okay.
All right. So, all right. So we're gonna set this up. Okay. So to set up the orange rectangle, that integral is gonna go from. First of all, where is this orange rectangle? Where are we setting it up from? Where does this rectangle stack? 0 to 2. If I do top minus bottom, it's going to be the square root of x minus 0. Right? The top is square root of x, the bottom is 0. We're okay with that?
Yep, the next one's from 2 to
It's going from 2 to 4.
4.
Okay. So this rectangle, you can kind of imagine it, it's going from here to here. So we're gonna set it up from 2 to 4. And then the top function is still the square root of x. But the bottom function is x minus 2, and have a dx. Is everybody okay with that? Right, we had to, but does everybody see that you had to use 2 rectangles?
And why is the first one root x minus?
0, because the top function is root x, the bottom function is 0. Right? That's not the tricky part. First, does everybody understand we needed 2 rectangles? Now, something very crucial that I'm going to be using for the rest of the week is, you know what? There's actually there's 2 types of rectangles you can use. You can use vertical rectangles, right? And vertical rectangles have a width of dx, or you can use horizontal rectangles. And horizontal rectangles, shocker, do this. Okay? Now, here's the benefit. When you use a horizontal rectangle, do you see that you only have to use 1?
Mm-hmm.
Now, whenever you use horizontal rectangle, instead of top minus bottom, it's right minus left. Right? Okay, everybody see in this picture a horizontal rectangle is preferable?
Mm-hmm.
Now, when you use horizontal rectangles, the width of the rectangle is y, and so we're going to have an integral set up dy. We're going to have a bunch of stuff, and there's going to be dy. And because we're using dy, we need a whole bunch of y's here. We can't use x's. All right? So what does that mean? Well, what that means is that every function has 2 versions. This is the version you're used to. All right? Where it's y equals stuff with x. The new version, or the horizontal version, is you need x equals stuff with y. So this function, right, it generates that. What we have to do is solve for y, and so when I solve for x, this is going to give me x is equal to y squared. Does everybody see the translation of this is x is going to be x equals y squared? And the translation of this thing is going to be x equals y plus 2. Did everybody see those are the same thing? This is just the other version of this. But now we have y's. And so now, when I set up this integral, it's right minus left. So which is the right function? What's this function?
Y equals x
Y.
equals y plus 2.
Or the y plus 2. So I'm going to have y plus 2 minus, what's this function?
Y squared.
Y squared. And the last part is, where are we stacking them?
From
Now remember, it's y's that we're interested in. Where do our y's start? Where do our y's stop?
0 to 2.
Y values. Does everybody see 0 to 2? And so do the integral from 0 to 2. Now, if you're typing this in your calculator, don't use y. X is a lot easier. But if you were to type this in, like you would say the integral from 0 to 2, do x plus 2 minus x squared dx, right? The calculator doesn't care if it's x or y or z or theta. You care because it's a whole lot easier to put an x in than any other variable. Does this make sense? All right? So, you know, when you're a lot of times, particularly when you're starting out, you want to use you like vertical rectangles because that's what you're used to. But sometimes they force the issue where you have to use horizontal rectangles. Okay. Does this make sense? All right? Last example. Yeah. It's kind of related to the other one, one of the previous problems. What if I give you y is equal to x cubed and y is equal to x?
What does x cubed look like again? It just.
It's an S thing.
It's an S.
A little squiggle. All right, so I'm going to draw this. So x cubed. Yeah. And then when I draw y equals x, that's this. And I'm going to even going to tell you that this is going to be the coordinate 1, 1. This is going to be the coordinate negative 1, 1. Actually, on the screen, it doesn't look that bad. I don't think it looks great with how I drew it, but all right, everybody okay with this? Everybody see the two regions? So when I draw my rectangles, here, let me draw this one. So if I set up this integral, how would I set up, how would I find the area that's sort of generated by that blue rectangle? Where am I setting my integral up from? I know, but where does it start? Where does it start? It goes from where to where? It's going to go from -1 to 0. And what's your top function? The x cubed. What's your bottom function? X. All right. So why am I doing this? I mean, you could draw another one here, couldn't you?
It's the opposite, so why would you? Because you cancel out. Yeah, they're odd functions that you cancel out.
No, no, no.
Oh, just.
This area plus this area,
It's just times 2.
it's just times 2. Do you see that this is the exact same area?
Oh, yeah, we're not doing negative.
Yeah. So since this is the exact same area, if I wanted to find this total thing, use symmetry. Anytime you see, oh, it's the same thing on the left and the same thing on the right, or this is the same shape, we could just multiply it by 2. Does that make sense? Do you see all of this hinges on the fact that you've drawn a picture and you draw a rectangle? Now, some of you might look at this and say, I don't need to draw rectangles. Yeah, you do. Things are about to get really interesting tomorrow, and everything that I'm going to teach on these really interesting problems hinges on you drawing a rectangle. I mean, literally, like tomorrow I'm going to take the rectangle and spin it around. Or I'm going to take the rectangle and start growing things. Okay? So that's the last topic.